Good afternoon. Good afternoon to one and all. Good afternoon. Hello. My voice is visible to you.
Good afternoon, ma'am.
Good afternoon. Audible to you?
Yes, ma'am.
Yeah. Okay. Shall we start today's lesson? కొంచెం నెట్ ఈరోజు ఫ్లక్చువేషన్స్ ఉన్నాయమ్మా, నాకు చెప్పండి. So today we will discuss about that different types of digital modulation techniques. That is second unit we will start. How many types of digital modulation techniques are present basically? So what is the importance of that one? And then we can compare every digital modulation technique with each other like this. So okay, now I am sharing my screen. Okay, second unit, digital modulation techniques. Basically, my voice is audible to you?
Yes, ma'am.
Okay. Screen? My screen is visible to you?
Yes, ma'am.
Okay. Basically, three digital modulation techniques. So these are the amplitude shift keying, phase shift keying, and frequency shift keying. There are three digital modulation techniques: amplitude shift keying, phase shift keying, frequency shift keying. First, here we can discuss the important features in this amplitude shift keying. The definition for ASK, amplitude shift keying, amplitude shift keying, ASK, is the amplitude of the carrier signal. The amplitude of the carrier signal is shifted according to the modulating signal. According to the modulating signal or data signal or the data signal. Amplitude of the carrier signal is shifted according to the modulating signal or data signal or digital signal. Here, previous classes discussed that is a data signal. In a digital communication, the information signal is a data signal that is in the form of digits. So let us assume the data signal here we can represent B of t is the data signal that can be represented like this: 1, 0, again 1 according to data, 1, 1, 0, 0 and 1, like this. Here we can represent this is a 1, 0, 1, 1, 1, 0, 0 and 1. So each bit duration that can be indicated, that is an TB, bit duration TB. So instead of, here the terminology is very important. Instead of speaking that modulating signal, called modulating signal, that is a message signal, here always here that information signal or modulating signal is a data signal. Data that is in the form of zeros and ones. That's why here we can represent that the input is a data signal that is in digital form. That is nothing but an information signal, message signal, modulating signal in digital communication. So whereas in carrier signal, here we can represent the carrier signal. Let us assume C of t indicates that the carrier signal, as usual, that is an high frequency signal. The carrier signal is an high frequency signal. We can represent this is an carrier signal. Carrier signal. Okay. Then what is the definition for amplitude shifting? The amplitude of the carrier is shifted according to this data signal. That means if there is a 1, the amplitude is present. Amplitude of the carrier is present. If the data signal is present 0, the amplitude is 0. And there is a 1, the amplitude of the carrier is present. If there is 0, the amplitude of the carrier is 0. Then here we can represent ASK signal, amplitude shift keying signal. So here we can represent there is a 1. So 1 unnadi kabatti the carrier itself is present. Amplitude of the carrier itself is present. Carrier is present. From this one, 0, bit 0 is present. Amplitude is 0.
మేడం వెయిట్ చేస్తున్నారు మేడం కొంచెం.
వెయిట్ చేస్తున్నారమ్మా. Okay. Then, shall I continue? Then, here there is a 1 is there. 1 is there from this one. 1 is there. The amplitude is present. Same waveform. And from this one, the data signal is 0, 0. The amplitude of that is 0. So this is an ASK signal. So what is the definition for ASK? The amplitude of the carrier is shifted according to the data signal. If the data is 1, the amplitude of the carrier is itself is present. If the data signal is 0, amplitude of that carrier signal is 0. Again 1, the amplitude of the carrier is present. This is an ASK signal. Okay na? Draw chesarama? Hello? Follow avutunnarama? Follow avutunnara?
Yes, ma'am.
Yes, ma'am.
Okay. Then the second one is PSK, phase shift keying. Second one is an phase shift keying. Note down the definition. The phase of the carrier signal is the phase of the carrier signal is shifted according to the data signal. According to the data signal. The phase of the carrier signal is shifted or changed according to the data signal. So here we can represent the data signal again B of t. This is an B of t. 1, 0, 1 and 1, 0 is a data signal B of t. And again carrier signal have to take the carrier signal this is the carrier signal. C of t and PSK signal, phase shift Kn. Let us assume if the data signal is 1, there is no phase shift, and if the data signal is 0, there is an 180 degrees phase shift that can be takes place. PSK, phase shift K. So in this one here, this is type of one is a BPSK, and here a quadrature QPSK also there. According to the data, that 4 phases of that is carrier is shifted to into 4 phases, that is QPSK and MRA PSK. The carrier phase that can be shifted into number of phases according to the data signal, that is an MRA PSK. Generally here we can represent PSK in the form of BPSK here. So if there is a one, there is no phase shift. There is no phase shift present. And there is an 0 at this one here, we can represent here positive, and this is a negative. Here we can represent that is a negative. Or again here that is an at this one positive is there. Here we can represent that is a negative. So like that here we can represent, we can indicate that for the sake of so one is there, the same that is present. If there is 0, we can represent and this is a positive, negative, and negative, this is a positive, and again here up to this one, this is a positive, this is a negative. There is a phase shift. Here we can observe that in this one. In this one, 180 degrees phase shift that can be takes place because there is a 0. Then in this one is there. Here there is no phase shift. There is no phase shift. Here we can represent the waveform is same. The waveform is like this. And again here there is an 0. The waveform is an so there is a 0 here. Up to this one here. Next there is a 0 here, that is positive, negative, and this is a negative, this is a positive, like this. So here we can observe that this is a carrier signal, one is there, the same phase that can be present. There is a 0, carrier signal is 1, and PSK signal 180 degrees phase difference. అక్కడ సో ఫేజ్ అప్ అంటే మనకి ఏమవుతుంది డౌన్ 180 degrees phase difference. నెగిటివ్ ఉన్నది కాబట్టి ఇక్కడ మనకి పాజిటివ్. ఇక్కడ పాజిటివ్ ఉన్నది కాబట్టి మనకి నెగిటివ్. Again there is a one is there, same the signal that can be repeated, same signal is present up to this. From this one onwards there is a positive, here this is a negative, and this is a negative, this is a positive. So like this here the phase of that carrier signal is changed or shifted according to data signal, that is a PSK. Then the third one is frequency shift keying. Frequency shift keying. What is the definition of this frequency shift keying? Anybody? Please tell me the definition for FSK. Hello? My voice is audible to you?
Yes, madam.
Okay, చెప్పమ్మా డెఫినేషన్ ఏంటి?
The frequency of the carrier signal is shifted according to the data signal.
Very good, very good. Then here we can draw this the data signal. We can draw the data signal. Let us assume this is a data signal 1 0 0 1 1 data signal. This is a data signal. We can represent the carrier signal is in C of t. Okay, this is a carrier signal. Next, FSK signal. Now here you can draw the FSK signal. Frequency shift keying signal. The frequency of the carrier signal is shifted according to data signal. So there is a one is there. The frequency of the carrier signal is increased. That is increased. Okay. So here up to this one is there. Here the frequency is one cycle is there for this in this duration. Only one cycle is there. But in this one the frequency is increased. And here it contains 2.5 cycles. That means that the time period of that carrier signal is reduced. That indicates that 1/t is the frequency that can be increased. Okay, there is an 0 0 0 is there. The frequency of that signal is reduced. The frequency of the signal is reduced. Okay, again there is a 1. The frequency of the signal is increased. The amplitude is constant. So this is an FSK signal. This amplitude is constant. Amplitude అనేది constant గా draw చేయండి. So here we can observe that there is a 1, the frequency is increased. There is a 0. ఇక్కడ చూడండి 0 0 ఉన్నప్పుడు ఎన్ని ఉన్నాయి పీక్స్ 1 2 3 పీక్స్ వచ్చినాయి. కానీ మనకి ఓన్లీ ఇంచుమించు 1 అలా వచ్చింది అంటే 1 సైకిల్. అంటే ఏంటి, టైం పీరియడ్ అనేది ఎక్స్టెండ్ అయిందంటే ఏంటి, ఫ్రీక్వెన్సీ అనేది మనకి రెడ్యూస్ అవుతుంది. 0 ఉన్నప్పుడు మనకి ఫ్రీక్వెన్సీ రెడ్యూస్ అవుతుంది, 1 ఉన్నప్పుడు ఫ్రీక్వెన్సీ అనేది ఇంక్రీజ్. Here also there is a 1, the frequency of the signal that can be increased. This is an FSK signal. This is an FSK signal, frequency shift keying. The frequency of the signal, carrier signal, is shifted according to the data signal. Amplitude of the data signal అనొచ్చు, or according to data signal. Amplitude అంటే in data signal లో మనకు always that represents zeros and ones. Zeros and ones. So these are the basic modulation, digital modulation techniques. One is amplitude shift keying, phase shift keying, and frequency shift keying. Are you understand the concepts of these digital modulation techniques? Emma? Okay. Shall we start binary phase shift keying? Okay. అర్థమైంది. ఓకే, నెక్స్ట్ ఐ విల్ స్టార్ట్ BPSK, బైనరీ ఫేజ్ షిఫ్ట్ కీయింగ్.
మేడం వెయిట్ చేస్తున్నారంట మేడం, ఒకసారి అలా చేయమన్నారు.
అలాగే అలాగే. So now we will discuss about that BPSK, binary phase shift keying. Binary phase shift keying. So in this one, the data signal is a binary data. So we can shift the frequency of the carrier signal, is phase of the carrier signal is according to that data. So that's why this is a binary phase shift key, binary data. The data is in binary. Only in this BPSK, the two phases that can be changes. If there is 0 phase of the carrier, that is there is no change in the phase of the carrier. If that is 0 is present data, so that is a 180 degrees phase shift that can be takes place according to that example. Here we can represent V of t is a data signal in this case. So we can represent the voltages. If that is plus 1 volt, represent logic 1. Logic 1. Minus 1 volt represents logic 0. Voltage levels for this one. These are very, very important. If that is a logic 1, if binary data, so 1 is there. Here we can represent the waveform. that is plus 1 volt waveform. And if 0 is present, that indicates that minus 1 volt. So that means here you can draw this one. We can represent here voltage waveform. One and minus 1, plus 1 volt. Here we can represent minus 1 volt. Here plus 1, logic 1, minus 1, that indicates that 0. So here we can represent this is a reference level. Here we can represent this is a reference. Like that, here we can represent the waveform for this one. And here the carrier signal C of t is the carrier signal that can be represented A into cos omega naught t. This is the equation for the carrier signal. So for this one here, you can find out the power of this carrier signal. Power PS represent PS is equal to power of this one, equal to, this is an RMS signal. Last class we discussed how to calculate the power of that signal, that is an RMS voltages. That is A by amplitude of that signal divided by root 2 whole square, that is equal to A square by 2. Therefore A equal to root of 2 PS, root of 2 PS. Therefore here we can rewrite this one in the place of A. Here we can write 2 into PS cos omega naught t. Cos omega naught t. Equal to root of 2 PS cos omega naught t is the carrier signal. That means actually here we can represent the carrier with in terms of amplitude, in terms of power lo represent chesam. Same A cos omega naught t anna okate, root of 2 PS cos omega naught t anna okate annamata. ఎందుకు ఇలా రిప్రజెంట్ చేసాము అంటే ద నొటేషన్ ఇస్ వెరీ వెరీ ఇంపార్టెంట్. పవర్స్లో మనం రిప్రజెంట్ చేయడం అనేది ఫర్దర్గా చాలా ఇంపార్టెంట్ ఉంటుంది కాబట్టి హియర్ వీ కెన్ రిప్రజెంటెడ్ లైక్ దిస్. సేమ్ రెండు ఒకటే. దెన్ హియర్ వాట్ ఈస్ ద ఈక్వేషన్ ఫర్ బీపీఎస్కే సిగ్నల్? బీపీఎస్కే సిగ్నల్ ఏంటి? బీపీఎస్కే వన్ ఈస్ there is no phase shift. If that is a 0 is there, 180 degrees phase shift that can be takes place. So 180 degrees. Let us assume the BPSK signal. Actually we can represent BPSK of T. ఇలా represent చేస్తారు. Notation also very very important. So sir, is a carrier signal. B suffix BPSK of T and represent చేస్తున్నాం కదా, that is nothing but a, that is BPSK signal అనే representation equal to, so root of 2 PS cos omega naught t, where b of t equal to 1, that is in plus 1 or logic 1, and this is also equal to, or మనకి ఏదో ఒకటి ఉంటుంది ఎప్పుడైనా రూట్ ఆఫ్ 2ps minus, here we can represent minus, or otherwise here after that I will represent minus. Otherwise here root of 2ps cos of omega naught t ప్లస్ ఎంత మనకి ఫేజ్ షిఫ్ట్ అవుతుందన్న యాంగిల్ ఏదో షిఫ్ట్ అయ్యేది ఒమేగా నాట్ టీకి యాంగిల్ ఎంత షిఫ్ట్ అవుతుంది 180 డిగ్రీస్ 180 డిగ్రీస్ పై యాడ్ చేస్తాం అంటే యాక్చువల్ యాంగిల్ కి పై అనేది వస్తుంది ఎప్పుడు మనకి b of t equal to 0 or minus 1 here. 0 అంటే మనం ఎలా రిప్రజెంట్ చేస్తాం -1 వోల్ట్, 1 అంటే ఎలా రిప్రజెంట్ చేస్తున్నాము +1 వోల్ట్ గా రిప్రజెంట్ చేస్తాం. అంటే ఇప్పుడు దీన్ని ఎలా రాయొచ్చు మనం ఈ సెకండ్ ఈక్వేషన్ ని cos ఆఫ్ θ ప్లస్ పై ఏమా పై cos ఆఫ్ θ ప్లస్ పై ఏమవుతుంది మైనస్ cos θ తెలుసు కదా అది ఏమా. That's why here we can write minus into root of 2ps.
Madam.
Amma, cos of wait చేస్తున్నారా ఒక్క నిమిషం cos of omega naught t. Okay, two equations are there. b of t plus 1 volt 1 అంటే లాజిక్ 1 ఉన్నప్పుడు root of 2ps cos omega naught, as it is there is no phase shift. Or if b of t is -1 volt, that is that equation is root of 2ps cos of omega naught t plus pi. That means minus into root of 2ps cos of omega naught t. Okay. దెన్ సో మనకి ఇప్పుడు ఏముంది మనకి సో +1 వోల్ట్ ఉన్నప్పుడు రూట్ ఆఫ్ 2ps కాస్ ఒమేగా నాట్ ఉండాలి. b ఆఫ్ t -1 వోల్ట్ ఉన్నప్పుడు దట్ ఈస్ లాజిక్ 0 ఉన్నప్పుడు మైనస్ అంటే ఫేజ్ షిఫ్ట్ అవ్వాలి. సో దానికి జనరలైజ్డ్ ఎలా రాస్తున్నారంటే ఈక్వేషన్ హియర్ వీ కెన్ రైట్ ద జనరలైజ్డ్ ఫార్మ్ ఫర్ the BPSK signal. BPSK of t equal to P of t multiplied with root of 2ps cos omega naught t. ఏమో b of t అనేది ఇక్కడ ఏంటి బైపోలార్ వేవ్ ఫార్మ్ దట్ ఈస్ ఫ్రమ్ +1 వోల్ట్ టు -1 వోల్ట్. ఇఫ్ డేటా సిగ్నల్ ఇస్ 1, b of t డేటాను ఎలా రిప్రజెంట్ చేస్తాము బై వేవ్ ఫార్మ్. By waveform here we can represent like this. This is a b of t. Here we can remember in this one waveform lo represent cheyalante data signal ni bipolar lo represent chestamu. Bipolar ante two polarities. దట్ ఈస్ ప్లస్ అండ్ మైనస్ వోల్టేజెస్లో రిప్రజెంట్ చేస్తాము బైపోలార్. ఇక్కడ +1 volt and -1 volt. Okay, so that's why here b of t is an +1 volt. As it is, there is no polarity change. Root of 2 ps cos omega naught t is present. If b of t is -1 volt, that is minus into root of 2 ps cos omega nt. So this is a generalized equation for BPSK signal. This is a generalized equation for BPSK signal. Okay. Then generation of BPSK signal. Generation of BPSK signal. Generation of BPSK signal. ఇక్కడ ఏమేమి ఉన్నాయి BPSK సిగ్నల్ జనరేట్ చేయాలి అంటే హ్యావ్ టు టేక్ వన్ డేటా సిగ్నల్ అండ్ వీ హ్యావ్ టు టేక్ అందర్ వన్ ఇస్ ద క్యారియర్ సిగ్నల్. ఆ రెండింటిని మల్టిప్లై చేస్తే సరిపోతుందా ఏమా? My voice is audible to you? Hello? Follow అవుతున్నారా?
Yes,
Hello.
ma'am.
Okay. So here we can take, instead of taking multiplier, ఇక్కడ రెండు మల్టిప్లై చేస్తే సరిపోతుంది డేటా సిగ్నల్ అండ్ క్యారియర్ సిగ్నల్, అవునా కదా? ఇన్స్టెడ్ ఆఫ్ టేకింగ్ దట్ మల్టిప్లయర్, హియర్ వీ కెన్ టేక్ బ్యాలెన్స్డ్ మాడ్యులేటర్. Balanced modulator. Another name of this balanced modulator is a product modulator. So for this balanced modulator, the input is, one of the input is B of t, that is the data signal. Again I will draw this one. We can represent the data signal as bipolar here. This is an +1 volt. Here we can represent this is a -1 volt. Then second input to this one is a carrier signal, root of 2 ps into cos omega naught t. Therefore the output of this balanced modulator, like previously చెప్పాను, multiplier కంటే have to choose the balanced modulator. So multiplier is a non-linear device. To multiply these two, there are so many components that can be obtained at the output of that multiplier. So how to filtering that unwanted components is complicated by using that multiplier non-linear device. But in this case, in balanced modulator, we all are studied about that balanced modulator. Two types are there. One is an product that is a ring modulator, another one is an balanced modulator. So in this case here, that is an in both the cases, other frequency components are very, very less. That is unwanted components, frequency components are very, very less. One or two components are present when compared with that multiplier. So that's why here, by using that filters, easily we can filter out that unwanted components when we are using balanced modulator when compared with the multiplier. That's why here we can use balanced modulator when compared with the multipliers. మల్టిప్లయర్ యూజ్ చేయాలి అంటే ఏమవుతుందంటే మల్టిప్లై చేసిన తర్వాత రిజల్టెంట్గా వచ్చే కాంపోనెంట్లో మన వాంటెడ్ సిగ్నల్తో పాటు అన్వాంటెడ్ సిగ్నల్స్ కూడా ఎక్కువ వచ్చేస్తూ ఉంటాయి అన్నమాట. ఎందుకంటే దట్ ఈస్ అ నాన్ లీనియర్ డివైస్. అదే బ్యాలెన్స్డ్ మాడ్యులేటర్కి వచ్చేటప్పటికి బ్యాలెన్స్ చేసి ఓన్లీ వాంటెడ్ సిగ్నల్ వస్తుంది. అన్వాంటెడ్ సిగ్నల్ అంటే మనం ప్రీవియస్ క్లాసులో మనం అబ్జర్వ్ చేస్తాం, ఓన్లీ లో ఫ్రీక్వెన్సీ కాంపోనెంట్ ఒకటి వస్తుంది, అందరూ వన్ ఇస్ అన్, అది కూడా మనం ఎలిమినేట్ చేసేయచ్చు ఈజీగా. అందుకని ఏంటంటే తక్కువ కాంపోనెంట్స్ వస్తాయి, ఈజీలీ వీ కెన్ ఫిల్టర్ అవుట్. అంటే డిస్టార్షన్ ఆర్ అన్వాంటెడ్ కాంపోనెంట్స్ అలాంగ్ విత్ దట్ వాంటెడ్ కాంపోనెంట్స్ by using balanced modulator is very very less compared with the multiplier. That's why here you can choose the balanced modulator. Then the output of this balanced modulator is B of t multiplied with root of 2ps into cos omega naught t. So this is our desired BPSK signal. By using balanced modulator, we generate the BPSK signal. Okay, Namma? So next class we will discuss about that receiver block diagram of BPSK. Okay? ఓకే, నోట్ చేసుకున్నారు అందరూ ఇదంతా? All of you? Hello? Emma, my voice is audible to you?
Yes, ma'am.
ఈరోజు చెప్పింది ఫాలో అయ్యారమ్మా లెసన్? ఫాలో అయ్యారా? ఎనీ డౌట్స్ ఇన్ దిస్ సెషన్? ఏమైనా డౌట్స్ ఉన్నాయా ఏమా? ఓకే ఓకే, థ్యాంక్ యూ అమ్మా. హలో,
థ్యాంక్ యూ మ్యామ్.
థ్యాంక్ యూ. డౌట్స్ ఏమైనా ఉన్నాయా? ఏం మాట్లాడట్లేదు? అర్థమైందా ఈరోజు టాపిక్?
అర్థమైంది మ్యామ్.
ఓకే అమ్మా, ఓకే, థ్యాంక్ యూ.
థ్యాంక్ యూ మ్యామ్.
ఓకే.